Hi friends, welcome back to 4th lecture of Class 10 Science, Chapter 10, Light. In this video, we shall start refraction of light. So light seems to travel along straight line path in a transparent medium. But what happens when light enters from one transparent medium to another? So still, does it travel in a straight line or does it change its path? Let's understand this with the help of an example. So when we partly immerse a pencil in water, then it appears to be bent. This is because of refraction of light. So light always doesn't travel in the same direction in all mediums. The change in direction of propagation of a ray of light when it travels obliquely from one medium to another medium is known as refraction of light. During refraction, we have two types of mediums, the denser medium and the rarer medium. The denser medium is the one in which the particles are more closer to each other, while in rarer medium, the particles of medium are more away from each other. So the denser medium, it is more dense as the particles are more close to each other, while in rarer medium, the particles are more away from each other. Also, refraction is of two types, from rarer medium to denser medium, and the second is from denser medium to rarer medium. So let's understand both of them with the help of examples. In the first case, the light travels from the rarer medium to the denser medium, and example is refraction through a glass slab. So in this case, air is a rarer medium and glass is the denser medium. The light ray which hits the glass is known as incident ray. And in this case, in this diagram, you can see that the incident ray is ray AO. Now when this ray AO falls on the glass, it travels from the air, that is the rarer medium, to the glass, that is the denser medium, then it undergoes refraction. And the refracted ray is ray OB. So the original path of ray AO is shown by the dotted line. But due to refraction, it gets bent towards the normal. So you can see that ray OB is slightly bent towards the normal, while the original path is not bent. From this, we can conclude that a light ray bends towards the normal while traveling from rarer medium to denser medium. Now let's study the second case of refraction in which the light ray travels from the denser medium to the rarer medium. So it travels from the glass to air. Now again we will take the same example in which the light ray is traveling from the glass slab to the air. And now in this case, the ray OB, which was earlier was a refracted ray, for this case it becomes our incident ray. And ray BC is known as emergent ray, and this is the ray which is coming out. As it is coming out, it is emerging out of the glass. That's why it is known as the emergent ray. Now in this case, again refraction will take place. The original path of ray OB is shown by our dotted line. But if we draw a normal, then we can see that ray BC is slightly tilted, it is slightly bent away from the normal. So it is bent away from the normal. This is the original ray and this is the ray BC, which is bent slightly away from the normal. So a light ray bends away from the normal while traveling from a denser medium to a rarer medium. From this we can conclude that if it moves from rarer to denser medium, then it bends towards normal. If it moves from denser to rarer, then it bends away from normal. Now, there are few more terms associated with refraction. First, angle of incidence. This is the angle between incident ray and normal, and it is denoted by angle I. Second, angle of refraction. This is the angle between refracted ray and normal, and it is denoted by angle R. Third, angle of emergence, denoted by angle E. This is the angle between emergent ray and normal. So basically, during refraction through glass slab, we studied that there are three types of rays. The incident ray, which falls on the mirror, which falls on the glass. Then second, the refracted ray, which gets bent away, gets bent towards the normal. And third, the emergent ray, which finally leaves the glass slab and bends away from the normal. So from this, we have another very important conclusion, a very important relation. That is, angle of incidence is always equal to angle of emergence during refraction. Now, we have few important laws of refraction. The first law says that the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. You can refer to the diagram. Second, the second law says that sine of angle of incidence upon sine of angle of refraction is constant. So basically, this law is also known as Snell's law of refraction, and it says that sine angle I upon sine angle R is constant, and this constant is known as refractive index. Now let's study more about this constant, that is refractive index. So refractive index is also denoted by small n, and it depends upon the speed of light in the two media. So one formula of refractive index which we have already studied is that refractive index is equal to sine I upon sine R. But apart from this, we also have few other formulas. The first formula says that n21 is equal to speed of light in medium 1 upon speed of light in medium 2. Here n21 is a refractive index of medium 2 with respect to medium 1. So it doesn't mean n21, it means the refractive index of medium 2 with respect to the medium 1. And its formula is that n21 is equal to speed of light in medium 1 upon speed of light in medium 2. Similarly, if we take the reverse, that is if we take n12, that is if we take the refractive index of medium 1 with respect to medium 2, then we will get the reverse. We will get that n12 is equal to speed of medium 2 upon speed of medium 1. In this way, refractive index depends upon the speed of medium. Now let's discuss about absolute refractive index. So its formula is absolute refractive index is equal to speed of light in air upon speed of light in the medium. So in this case, the numerator is always considered as constant, and that constant is the speed of light in air, which is 3 into 10 raised to power 8 meter per second. And in the denominator, we take the speed of the light that is given for the medium. And usually, when we talk about the absolute refractive index, we mean that it is a refractive index. So many times the absolute refractive index and the refractive index are taken as same. So here we have a very important numerical based upon refractive index. The question says that light enters into a glass plate with having absolute refractive index of 1.50. What is the speed of light in the glass? And this is an NCERT in-text question. So the answer is that absolute refractive index is equal to speed of light in vacuum or speed of light in air upon the speed of light in the medium. So in this case, we always know that the speed of light in vacuum or air is 3 into 10 raised to power 8 meter per second. So we will take it in the numerator. And in this case, we have to find the speed of light in glass. So the medium becomes our glass plate. And let's take the speed of light in glass to be V. Let's denote it by V. So basically, we will get that 1.50 is equal to 3 into 10 raised to power 8 upon V. Now if we take the V to the other side, and if we take the 1.50 the new denominator, that is if we transpose both of them, then we will get that V is equal to 3 into 10 raised to power 8 upon 1.50. Now you just have to solve do the mathematics and solve the question, and you will get that V is equal to 2 into 10 raised to power 8 meter per second. So this was all about this lecture. In the next lecture, we shall discuss more about refraction of light. So stay tuned.